Welcome to ThinkSmart.life. If you've been wanting to run AI on your own hardware but feel overwhelmed by the specs, this video is exactly for you. No fluff, no filler. Just the honest breakdown of what actually matters, what you can skip, and the exact builds that work at every budget in 2026. Why run AI locally in the first place? Three big reasons. First, privacy. When a model runs on your machine, your prompts never leave. No API logs, no training data harvesting, no compliance headaches. For anyone handling sensitive information, lawyers, doctors, developers, this alone is the entire argument. Second, speed. Local models respond instantly. No round trips to a data center, no rate limits, no queues. Once you've used a local model at 30 tokens per second, going back to a sluggish API feels painful. Third, cost. GPT-4o charges per token. A local model, once you've paid for the hardware, is free forever. If you generate a lot of text, coding, document work, agents' local inference pays for itself fast. And fourth, control. You choose the model. You run it 24/7. No one can change pricing, deprecate a version, or shut it down. Before you spend a single dollar, understand the one rule. VRAM is everything, not CPU speed, not system RAM, not core count. VRAM, the memory on your GPU. Here is why. When you run a language model, its weights, all those billions of numbers, need to live in GPU memory while the GPU processes them. If the model fits entirely in VRAM, the GPU runs at full speed, 30 to 60 tokens per second. If it does not fit, the system starts shuffling data between GPU memory and system RAM, a process called CPU offloading, and performance drops to 2 to 5 tokens per second. It is not a gradual slowdown. It is a cliff. One side is fast, the other side is painful. Your job is to make sure your model fits. So what does VRAM actually get you? Here is the breakdown at Q4 quantization, which we will cover in a moment. 8 gigabytes of VRAM gets you a 7B model, barely. It is the minimum, but not where you want to be. 16 gigabytes gets you a 14B model at Q4 or a 7B model at high quality. That is real performance. 24 gigabytes, this is the sweet spot, gets you a 35B model at Q4. And that is where local AI becomes genuinely powerful. 32 gigabytes gets you a full 70B model at Q4. That is GPT-4 class capability running locally, privately, forever. The jump from 16 GB to 24 GB is enormous. With 16 GB, you are running solid models. With 24 GB, you are running models that compete with frontier APIs. Now the GPU decision. In 2026, here is how the tiers break down. The Budget King, a used RTX 3090, 24 gigabytes of GDDR6X, 936 gigabytes per second of memory bandwidth for around $700 on the used market. This is the best value in local AI right now. It launched in 2020, but for inference workloads, which are memory bandwidth bound, not shader bound, it is still excellent. For a new build, the RTX 4070 Super at around $800 gets you 16 gigabytes of fast GDDR6X, a great starting point for a new build. The RTX 4090 at $1,600 is the fastest consumer 24 GB card you can buy. And the new RTX 5090 at $3,000 finally adds 32 gigabytes of GDDR7, enough for 70B models without any CPU offloading. If you want the new consumer king and can justify the price, that is it. Apple Silicon deserves its own section because it plays by different rules. On a Mac with M-series chips, VRAM and system RAM are the same physical memory pool. There is no separation. A Mac Studio M3 Max with 128 gigabytes has 128 gigabytes of effective GPU memory. That is more than any single consumer NVIDIA card. With 128 gigabytes, you run a 70B model at full precision, multiple models simultaneously, and larger models than any RTX 5090 can handle. The trade-off? Apple Silicon has far fewer floating point operations per second than high-end NVIDIA. An RTX 4090 delivers around 82 teraflops. An M4 Ultra delivers around 21. For inference, which is dominated by memory bandwidth, not flops, the performance is competitive. For training or fine-tuning, NVIDIA wins decisively. The Mac Studio M3 Max at about $3,500 is a compelling machine if you want everything in one box, polished, quiet, and enormously capable for local AI. Beyond the GPU, three components matter. System RAM, 64 gigabytes minimum. This surprises people, but you need RAM for the OS for loading models before they hit VRAM, for embeddings, vector databases, and the apps running alongside your AI stack. On 32 gigabytes, you will constantly hit the wall. CPU, mostly irrelevant for GPU inference. The GPU does the work. The CPU tokenizes prompts and manages I/O for a new build. The Ryzen 7 7700 on AM5 for around $180 is the right answer. Fast, cheap, never your bottleneck. Storage, 2 terabytes NVMe minimum. Models are huge. A 70B model at Q4 is 40 gigabytes. You will collect more models than you think. Use NVMe, not a spinning drive. Loading a large model from NVMe takes 20 seconds, from a hard drive minutes, and size your power supply correctly. AI workloads run GPUs at near maximum TDP continuously. RTX 3090 needs at least 750 watts, RTX 4090 needs 850 watts, RTX 5090 needs a full kilowatt. Get 80 plus gold or platinum from a reputable brand. Quantization is the technique that makes local AI practical on consumer hardware, and it is completely free. It is just how you download models. Here is what it does. A language model's weights are billions of decimal numbers. At full precision, FP16, each number takes 2 bytes. A 70B model at FP16 is 140 gigabytes. That does not fit on any consumer GPU. Q4 quantization compresses each weight from 16-bit precision down to 4-bit, reducing memory by roughly 4 times. That 140 gigabyte model becomes 40 gigabytes. It now fits. The quality loss is smaller than you would expect. On most benchmarks, Q4 degrades performance by 3 to 5%. For coding, writing, and reasoning tasks, you often cannot tell the difference in practice. Q6, 6 bits per weight, is barely perceptible from full precision and is the sweet spot if you have the VRAM headroom. Think of it this way: quantization doubles your effective VRAM. A 24 gigabyte GPU can run models that would otherwise need 48 gigabytes. When you download models from Ollama, they are already quantized. You just pick the level based on your VRAM. The software stack to get started is simple. First, Ollama. It is the easiest way to run open source models locally. One command downloads the model, sets up quantization, and starts an inference server. It works on NVIDIA, AMD, and Apple Silicon. Install it, then run Ollama Run Llama, and you have a local model answering in seconds. Second, Open WebUI. It is a free, self-hosted web interface for Ollama that looks like ChatGPT. It runs in Docker, opens in your browser, handles conversation history, multiple models, and file uploads. You run one Docker command and have a local ChatGPT at localhost 3000. Third, if you are on Windows, LM Studio. It is a native GUI app. Download models directly, switch between them, and get a chat interface built in without any Docker required. First models to try: 5.4 Mini for fast tasks, Llama 3.2 for a solid baseline, QN2, 5, 14B for coding and reasoning if you have 16 GB, and QN2, 5, 32B if you have 24 GB, one of the best all-rounders available. 2 concrete builds. Build 1, the Budget King, around $1,500 total. GPU, used RTX 3090 24 GB for about $700. CPU, Ryzen 7 7700 on AM5 for $180. Motherboard, B650 for $140. RAM, 64 gigabytes DDR5 for $150. Storage, 2 terabyte NVMe for $100. PSU, 850 watt 80 plus gold for $110. Case and cooler, $80. This build runs 35B models at Q4, generates at 15 to 25 tokens per second, and competes with frontier APIs. It is the best value you can build for local AI in 2026. Build 2, the sweet spot, around $1,800. Swap the GPU to an RTX 4070 Super at $800, 16 GB of fast GDDR6X, brand new with warranty. You lose 8 GB of VRAM versus the 3090 but get a newer card. Pair with Ryzen 7 7700X, 64 GB DDR5, and 2 TB NVMe. For the Mac path, Mac Studio M3 Max with 128 GB starts at $3,500. More expensive, but it runs 70B models at full precision and integrates seamlessly into macOS. Here is how to start tonight. Step 1, go to Ollama.com and install Ollama. It is one command on Linux and Mac, a simple installer on Windows. Step 2, run Ollama pull QN257B in your terminal. It downloads the model automatically and you are running it in minutes. Step 3, install Open WebUI via Docker for the full ChatGPT style interface. That is literally it. You can be running a local AI model tonight on hardware you already own. The full article with all the specs, comparison tables, and build lists is at ThinkSmart. life/research/post/local AI hardware starter guide. If this helped you, subscribe. We publish deep technical guides on local AI, model architecture, and building real AI systems every week. The local AI revolution is not coming. It is already here. The question is whether you are running it on someone else's hardware or your own.